Important here is that you were not allowed to actually round this value off. So this value you had to keep in the calculator, or you could just use the answer button to get this value. And then your reference angle was 75,14, and you actually had to state the second solution in this case. Remember when you're using sine rule to find an angle, you have to check whether the second solution would be valid. So if this is the second solution, if you add 42 to it, it's still less than 180. All right, so you would still have space for angle B. So the second solution is valid in this case. Right, number 4 and 5 were just like the second or the first example that we did yesterday. So the 3 sides were given and you had to find an angle. So you would just use cos rule for that. Remember guys, like I said yesterday, when you're using cos rule to find an angle, you always start your cos rule out with the side that is opposite the angle that you're trying to find. So if you're finding angle B, you have to start with the side opposite that angle, which is 10.8 squared. Because that then allows you to have the opposite angle x in your actual cos rule on the right hand side there. Then what I did in this case, I did actually simplify this first. So I multiplied 2 and 14.2 and 16.3, negative 2 in fact. So over here it was negative, this whole term was negative 462,92 cos x, which is what I moved to the other side, right? And that whole term then became positive. But guys, if you want to, like we did in the example yesterday, you can keep writing 2 times 14.2 times 16.3 cos x, that's fine. Then I moved this 10.8 squared to this side and it became negative 10.8 squared. So that plus that minus that is 350.69. Again, it's fine if you left it as the 3 separate terms, nothing wrong with that. That's what we did in the example. Then to get cos x on its own, you take whatever you have on the right hand side, the whole thing, and you divide it by this. And I got 0,757 with a bunch of other decimals. Then you do shift cos, answer, and you get your value for x. Just hold on, where is cos positive again, guys? 1 and 4. So we do our first quadrant solution, which is just the reference angle. So you don't actually have to write reference angle. Okay, you can just write x straight away. We disregard the fourth quadrant solution because 360 minus, that can't be an angle in our triangle. Okay? No, you can actually I'm just the person on the square. So for the cos part, we found AB, but the actual one doesn't find angle A. Find AB first and we'll clear that. Right, guys, same thing in number 5, but what happened in number 5 was when you solve for cos x, so answer was actually negative, right? Negative a quarter, negative 0.25, if you wanted to write it like that. So now you need to ask yourself, where is cos negative? Quadrants 2 and 3. Will we do the third quadrant solution, 180 plus? No, that's too big of an angle to be in a triangle, but we will do 180 minus. Now for this one, I did write the reference angle down because remember guys, when you're solving for x here, if it's a negative value, you're going to have to do shift cos of positive a quarter. Remember, you don't type in shift cos negative a quarter. That will actually give you a negative angle, okay? So here, to get this reference angle, you would do shift cos of positive a quarter. But that's not your answer. That's not your x value. That is just the acute angle. That's the quadrant 1 angle. To get your quadrant 2 solution, which is your actual x value, you would have to do 180 minus this. Okay, so if you're writing 75.52 anyway, you have to label it as reference angle. You can't write that that is x. It's not. Okay, you have to then use reference angle for that one. Yeah. With trig rations, you always have to do that. With sine, it's just you can get two solutions because the quadrants are 1 and 2. Okay. So both of those quadrants could give you an angle and a triangle. Where with cos, it will just be one of them. Okay. Any other questions, guys? Robin?
I can also do the whole reference angle.
Mhm. Yeah. Shift cos negative a quarter and you got this.
Yeah.
Oh. Because I thought you get a negative value and then you would have to add 180. Let me just check. Shift cos negative a quarter. Oh yeah, that actually works. Won't work in all cases though, because if you are doing it with sine, for example, you'll get a negative angle where you have to then, yeah, so it's fine. I mean, I suppose that happened by accident. Yeah, just try and remember that you're actually supposed to do the reference angle first. Yeah.
The area is always the two adjacent sides next to the angle.
Yeah, so it's always the angle in between the two sides that you have to use. Okay, let's look at revision number 1, which I think was, sorry, yeah, it is number 1. I think this was a bit easier than the previous one, but yeah, so for 1.1, you had to find side x. So I thought, okay, let's check if I can use sine rule. So I have the opposite angle there, but then I don't have another pair. So I would have to find that angle there. Then I have another pair. So I found A just using angle sum and triangle. So A was 78. And then I used sine rule from there. You can see number 2 there as well. It was again finding an angle using sine rule, and both of the solutions were valid for that one, for number 2. Oops, so I wrote down both of them. There is number 3, very straightforward. You could just use cos rule straight away to find x. Okay, let me check that quickly. I think they said for this one.
No, but I mean like within the
It is 1946. So if they say it's around to 2 decimal places, you only look at the third one. Yeah, yeah. Okay, 1.4 is over there. So here you had to use cos rule to find that angle. So that's like the last 2 from exercise 3 that we just did. So again, because we're finding this angle, we need to start with the side that is opposite that angle. Here, again, I calculated this. This was 1,680, negative 1,680, which I then moved. It became positive. I then moved this 38 squared to the other side. So I did 35 squared plus 24 squared minus 38 squared, and I got that. Then you divide. And then this is positive. So cos is positive in 1 and 4, but we ignore 4. So you can just write x straight away, shift cos of that value, and you get your answer. Yeah. With sine rule, when you're finding an angle, you always have to check for a second solution. So you do always have to calculate it on the calculator. So we got 102.8. Then you look in the picture, what other angle did they give you? 47. Now, if you add 102 and 47, that's still 149, which is less than 180. So then it's valid. If it gave you something that's bigger than 180, then it can't be the second solution.
And so you don't have to write it in invalid, you just don't have to write it.
Yeah. Okay, last two, and then we're moving on. 1.5, 1.6, you had to find the areas here. Here we go. Now guys, in 1.5, it was straightforward. You had the two sides and the included angle. You could find the area straight away. So it was half 21 times 28 times sine of that one. Remember, please, the area rule uses sine. Okay, that's important. For 1.6, you could have done it differently, but you still would have gotten to the same answer. We can check that now. In 1.6, they've given you only one side, but two angles. You need two sides and the included angle. So I decided that I was going to calculate AB. So that, just hold on. So that I can then use half this times sine of that one. But you could have decided to calculate AC. In which case, your working obviously would be different. So you would find AC using sine rule in a similar way that I found AB. Then you would say half of this times sine of 42. Right, so there were two possible solutions for this. I'm just going to explain quickly how I found AB. So AB is this side. I have the angle opposite to that side. If I want to use sine rule, I need another pair of a side and its opposite angle. So I have this 88. I don't have the opposite angle, but I can find it easily because I have the other two. So that was my first step, calculating A using angle sum and triangle. Angle A was 110 degrees. Then I used sine rule to find AB. So I said AB over sine 42 is 88 over sine 110. Then I multiplied the sine 42 on the other side. I got my value for AB. So AB was 62,66, which is a rounded value. So now when I use it in my area thing, I have to use the answer button. Okay, because AB is an in-between step. That's not the final answer. Then I did half times 62,66, but the answer button here, times 88 times sine of 28, and I got that answer. This now you obviously have to round because that's your final answer. Did anyone calculate AC instead? Jasper, what was it?
You get 43.96 is the round.
Okay, it is what you got as well. Okay, 43,96.
Actual area,
Is it slightly different?
it's bigger. Mine's
Smaller. Okay, yeah, it might, because it might differ like slightly, but it's not supposed to be that much of a difference. Okay, I'm just going to do it quickly. So that over sine 28 is that. Okay, so it's going to be 88 sine 28 over sine 110. Is that, yeah, okay, so that was the answer for AC. All right, so if you calculated AC, it was that. So then you would do 0.5 times answer times 88 times sine of 42. Yeah, so it does get to the same answer. There we go. All right, so if you work with AC instead, you still will get the same answer and you will get full marks, obviously, because it's a perfectly fine method. Yes. We'll just now. Are we all fine with this one, guys? All right, please write your new headings along. Application of the sine, cos, and area rules. Yeah.
Cos x equals negative quarters.
Yeah.
In the negative, what do you?
No, so in this case, it did actually work, but we just use the positive value always when we're finding the reference angle, just like when we did the trig equations. Yeah, the rule is that you put in the positive value, but you then work in the negative quadrants. So you would then take that reference angle and say 180 minus. Okay, application of the sine. Cos, it's fine if you just wrote cos, but I'm going to write cosine. Sorry, I did say cos, so it's fine, don't worry. And area rules. Okay, find the value of x. In the figure below. Right, guys, are we seeing that x is AP there at the bottom, that small side there? Now, what I want us also to notice is that we have three triangles here, actually. We have BCP, which is a right angle triangle. Remember, what can we use in right angle triangles? Pythag, okay, and what else? The normal trig ratios, right? Sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan, which is opposite over adjacent. So when we're working in this triangle, we can actually use those things. All right, so I'm going to write that on the side. This is not a part of the solution. We're just writing this down so that we can remember. Can use Pythag and sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. All right, of either one of those two angles. Then we have ACP, which is this smaller triangle on the side here, which is not a right angle triangle. So what are we going to use in that triangle when we have to solve for x? We can use sine rule and cosine rule and area rule. If they ask us to find the area, they're not asking us that in this case. All right, so we're not going to use that there. But in triangle ACP, we can use sine rule and cos rule. Then we have this big triangle ABC, which consists of both of them, which is also a right angle triangle. So we might be able to work in the big triangle as a whole. We might not need to, but we could. All right, so actually let's just add the plus triangle ABC. We can also use Pythag and sine, cos, and tan in the big triangle, right? The one that consists of both of them. If we need to, we might not need to, but that could also be an option. So guys, they've asked us to find x, which is a side of triangle ACP. All right, this x actually has nothing to do with the right angled one here. Do you notice that? X is the side of this triangle. Now, when we look at triangle ACP, we actually only have one piece of information there. We only have one angle in that triangle. Do you guys notice that? We only have that 55-degree angle. Now, we can find this angle, all right, using angles on a straight line. We can find that angle using exterior angles of a triangle or angle of a triangle. But guys, we have no sides in that triangle. And that's problematic because we can't use sine rule or cos rule to find a side, because that's what we have to find if we have no other sides. All right, if we want to use sine rule, we need the opposite angle, which we can find. All right, and then if we have that angle, we'll need the opposite side, which we don't have. All right, or if we have that angle, we'll need that side, which again, we don't have. If we want to use cosine rule to find a side, what do I need? The other two sides and the included angle. All right, I can find the included angle, but I don't have any sides. So bottom line here is that we're going to have to find at least one side before we can actually find x. Now guys, something that I want you to just highlight here or just color in or just indicate is side PC, CP. That is the common side between the two triangles. And that is 99.9% of the time the key to solving this question. If you find the common side, you will then most of the time be able to actually just solve the question from there. All right, I'm going to write here, not enough information in triangle ACP, therefore find the common side which in this case is CP. And we can find the common side because if we're looking at the other triangle, the right angle triangle, we have more information here. And CP is also actually a side in that triangle, right? So if I work in my right angle triangle, using sine or cos or tan, we'll figure out now which one we're going to use. I can find CP, and then I'm going to have a side in triangle ACP, right? Because this side is a side in both of our triangles, the right angled one and the non-right angled one. So that is the key, guys. Find the common side. If you get a question like this, you don't know where to start, identify the common side and find it. Okay, you will get marks for doing that at least. Okay, now if we're looking at this right angle triangle, I have this 75-degree angle, all right? I have the opposite side, 15. What is CP? What side is it in this triangle? It's the hypotenuse. Which trig ratio works with opposite and hypotenuse? Sine. So I'm going to say sine of 75 is 15 over CP. And then I can solve for CP. All right, like the first exercise that we did. Remember when we worked in just right angle triangles, the very first one. So we're going to say sine of 75 degrees is equal to opposite 15 over hypotenuse CP. To get CP on its own, first I must multiply it out on this side. So CP sine 75 is equal to 15. And then I must divide by sine 75, right? So then CP is equal to 15 over sine 75. Which is, oh, there we go, 15.53. Okay, we can write down a rounded value, but I'm actually going to do this so that we remember that we're not actually allowed to work with 15.53 in our next calculation. Because guys, did they ask us to find CP? No, that's an in-between step. So we are not allowed to actually round that off. You can write 15.53, but maybe just write it like this as a reminder that you would have to use the answer button. Yes. Yeah? Yes, you can. Okay, we found the common side. Does that help us, guys? If I just fill this in here, 15.53. Remember, we're trying to find x. So let's see, if I want to use sine rule, right? That's normally the first one that I look for because that's the one that I just need one side for. Okay, cos rule is one that we need two sides for. So x over this angle, so we're going to have to calculate that angle, is going to be this over sine 55. Okay, so we're almost there. We still need to find angle ACP. Now, like I said, there are two ways in which you could find that angle. You could go the longer route, which would be to use angles on a straight line to find that angle and then do angle sum in triangle. But let's try and save some time, guys. 75 is the exterior angle of this outer triangle. What do we know about the exterior angle? It's equal to the opposite interior angles. So 55 plus this angle must give us 75. So what must that be? 20. All right. So I'm just going to write that ACP. And if you don't want to figure it out like that, it's not always as easy to see that it's just a 20 that you would have to add. You can do a calculation. You can say the exterior angle minus the interior angle that you have. That will give you the other one. So you can say 75 minus 55 is equal to 20 degrees. And the reason there, exterior angle of triangle. Or you can just write 20, but that would be the calculation that you would have to do. Okay, so it's always the exterior angle minus the one that you have on the inside. Now we can use sine rule to find x. Okay, we now have all the information. So now we're going to say x over sine of 20, because the 20-degree angle is opposite x, is equal to 15,53, which we're going to use the answer button for, over sine of 55. And now we're just going to solve for x like we have been doing. We're going to multiply the sine 20 on the other side. Guys, every time that I'm doing this dot 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 thing, you're welcome to write just 15,53. You would type that in. So I'm just going to show you. I'm going to do my fraction button. I'm going to press answer. Sine 20 over sine 55 And the answer is 6,48. Okay, so guys, when you get a question like this where you have two triangles, and they will usually ask you to find a side or an angle in the triangle that has the least information. All right, so they'll force you to start working in the other triangle to calculate some stuff that you can then use in this one. I suggest that you look at the triangle that you have and you ask yourself, if I want to use sine rule, what do I need? All right, so if I have that, I need the opposite angle. If you want to work that out first, that's fine. You'll get marks for working it out. Okay, then I have that angle. I need to find that side. All right, which is the common side. Now, guys, you would have been able to do it if you could find AC as well, because you could find that angle there using angles on a straight line. But then if you want to use sine rule with this angle, you would need AC. Now, would there be a way in which we could find AC? If we just have the black stuff, right? We just had 15 centimeters and that's 75. We had the 55. Yeah. Yes, I could use sine in the big triangle as well, right? So I could say sine of 55 is 15 over this hypotenuse over AC, right? And then I could use sine rule, but then instead of working that angle out, you would have to calculate this one. Okay, so it would have been the same amount of work. All right, it still would have been fine. Okay, guys, you are going to work on exercise 5 in the textbook. It's page 221. I want you to do numbers 1.1 to 1.3 and those ones. Okay, the first 3 are just working with numbers. In the last 3, they have variables. Okay, so you're going to have to use the same method like the one that we used up here, but just working with variables and no numbers. Guys, I want to give you a hint for 1.1. They've given you a very strangely shaped quad. Just split it up into 2 triangles and then work from there. I'll put it on the board now, then you can see. Someone filled a bunch of stuff in my book in pencil. I don't know if it's correct, so just ignore that. Okay, can I put it on? There you go. 1, 2, 3. Yeah. Yes.
I'm getting one this weekend. So
Okay, yeah.
last time.
That's fine. It just doesn't work well, but they might. Oh, you're looking for 2 points. Yes, it is. All right, there we go. Thank you. Let's get going, please, guys. Less talking, more working. Let's go. Let's go.